So I would say beta is equal to lambda d by d is supposed to be one of the most important formula for all your calculations, for all your numericals. So lambda d by d. So I told you red, green and blue, right? So we have three lasers. Which one is having the highest wavelength? Red. Any idea what is the number? Anybody remember? 600. Approximately 600, right? So 600 to 700, somewhere in that order, right? Green is 530 nanometers. So this is, red is something like 632 nanometers. This is 532 nanometers, right? Sorry, this is blue, violet, and this is 532 nanometers, and this is something like the lowest one, right? Anybody remember the number? Something close to 400 something, right? So 400 nanometers. So I told you the gratings are something like to make it very small slits, right? So gratings are the best way to do it. You can have some double slits like this, but then it's not as effective as this. But still, the other day I think we right. I would say let us play with the diffraction gratings. So this is the first one is 100 LPI. That means the gap is going to be, the small d is going to be bigger or smaller compared to 250 LPI lines per inch. This is going to be, d is going to be bigger, small d is going to be bigger, right? As you increase the number of lines, the gap is going to get smaller and smaller. So that means, so just observe what's happening here. So this is the first one, 100 LPI. This is 250 LPI. This is 500 LPI. So what do you think is the difference? What's happening to the maximas? Maximas are getting farther away. Why? Beta is equal to lambda d by d. So as the small d becomes smaller, what happens to the beta? Beta increases, right? That's the understanding you should have. So again, let me show you one more time. So this is very close. All the maximas are very close. Here it is somewhat away, right? If you really go and measure it and put it over here, you will be getting the correct answer. So if you want, you can do a proper experiment. Okay? But again, because of time constraints, we don't have time. But if you want to try it, you can always sit here and do it or come early. And then I told you this is 500 LPI, and then this one is 15,000 LPI. That means it's going to be much more bigger. You see the difference? So as the d gets smaller, the beta gets bigger, right? So that is small d. So I showed you what happens if the d is changing, right? How to change the capital D? Just change the position, right? So look at this. So if I keep it here, it's like this, right? So the gap is very small. Beta is very small. So as I increase the capital D, what do you mean by capital D? The distance between the slit and the screen. So as I increase the capital D, I can see that it's going to be very big. So the gap is going to be, the beta is going to be bigger and bigger. So I want to bring the central bright at this point, right? So the central bright is somewhere here. So let me mark this here. So try to make it without saying. So this is my first order. This is also first order. The second order is somewhere here. Yeah. Okay. So now go to the green one. Again, try to bring the central bright exactly at this point. Central bright is here. So look at this one. So this is for green, this is for red, right? This is for green. So what has happened now? Lambda decreases means the bright beta also decreases, right? So compared to the red, green is lower, right? Can you go to the blue one? I don't know if the blue will work, but try that. So the reference is central bright fringe is here. So look at this. So this is blue here, this blue here. So the blue is here. So look at this. So we said it's something like this. But see what happens if I move this laser here. Is there any change here? So that means the source, where the source is kept, it doesn't matter. It's only between the slit and the screen. So that's why it is not appearing in the formula. So it doesn't matter where the actual source is. So actually what we are doing is, in the grating, right, you have some small slits like this. So I am sending a laser like this, such that this is very, very small, very, very close. So the same source is going through both the slits. Okay. So that means the point where I keep the laser does not matter. So this, the actual source, are you following it? So this is called source 1, source 2, meaning I am having one source here and that is getting split into S1 and S2, Young's double slit experiment. Okay, so it doesn't matter where you keep the actual source, matters only between the slit and this distance, or lambda d by d. Everyone okay with that? Okay, you may get a question, does the source distance from the slit, does it matter? The answer is no. Okay, so make a note of it.